13.1 practice problems, starting with number 3. Number 3 gives us this picture of a triangle. This is 90, this is theta. By the way, I don't think I explained this exactly in the other video. But theta is just a variable, just like x is a variable. It just stands in place of a number. And you don't call this O with a line through it or 0 with a line through it. It's called theta. Spell that for you. It's a Greek letter, and theta is used many times. It's very common to use for angles. Okay, just like x we use for just like a number in a problem, just whatever that number might be, x number of dollars or x number of people, we have theta degrees. Okay, so finish out this drawing, 10 and 24. All they want us to do is name and label, define all of the 6 trigonometric functions. Okay, so let's start out with just what we have. Okay, we've got this 10, this side 10, this side 24, and what are they in relation to theta? Well, this guy right here, neither one of these is the hypotenuse. The hypotenuse is what we don't know yet. So these are either opposite or adjacent. We look across from theta. The opposite side is 24. The adjacent side is 10. Opposite and adjacent. There's going to be 2 ratios that use those. There's going to be one, and there's going to be its reciprocal. And let's just name those 2 right now, because we already have those things. The opposite over the adjacent is the tangent. Or this could be 12 over 5. Okay. And if we know the tangent, then we know the cotangent, because it's just the same numbers, it's just flipped over, so it's going to be 5 over 12. Alright. Now to do the sine and the cosine and the secant and the cosecant, we need to have the hypotenuse. The hypotenuse is involved in all of those. So to find that, we need to use the Pythagorean Theorem and find the hypotenuse. Okay. This kind of stuff I just do on the calculator anymore, because it's just, you don't need to write it down, I guess. You're used to it. 24 squared plus 10 squared, 676, and you know that that's equal to the hypotenuse squared, which means you need to take the square root of the answer, 26. That's convenient. It's not a weird looking number. 26. So let's go on to the sine. Sine is the opposite over the hypotenuse. That's 24 over 26. That's 12 over 13. I'm just going to jump over here and do the reciprocal. Now you know that it's either the secant or the cosecant, because the cosine is going to go over here. And you may want to pair the cosine and the cosecant, because they they start with the same thing, and tangent and cotangent, and sine and secant, it would fit together so well. But just train your brain to warn you not to do that, because the reciprocal of the sine is called the cosecant. Okay, so you're just going to have to remember that. So the reciprocal of the sine is a cosecant. Reciprocal of 12/13 is 13/12. Go over to the cosine. The cosine is the adjacent over hypotenuse. The adjacent is 10. The hypotenuse is 26. This is 5 over 13. And the secant, the reciprocal of the cosine, is 13 over 5. The reciprocal of 5/13 is 13/5. Now let's squeeze in number 13 here. 13 gives us one of these ratios, the secant. And then it wants us to find all of them. Well, it only gives us this. What are we going to do? Well, what we can do, let's put it down here, because we can just kind of group everything up here together. Well, for one thing, the secant of theta, we know, we can say it's reciprocal, at least. The secant of theta is 12/5, so somewhere out there is one that is 5/12, so just remember what the name is. The reciprocal of the secant is, remember our little discussion down here, the reciprocal is the cosine. Okay, but how do I find the other 4? If the secant of theta is 12/5, what we're saying is there's an angle out there, right? Let's say that this is our angle theta, right? That's an angle. And that angle has a secant of 12/5. So what does that mean? That means if theta is in a triangle, a right triangle, then its secant is 12/5. The secant is the hypotenuse over the adjacent. It's 12 over 5. Obviously this picture is not to scale. But there you go. Here's an angle whose hypotenuse over its adjacent side is 12 over 5. And cosine as well, 5 over 12, the adjacent over the hypotenuse. Okay, so we can use this information to find the rest of them. We just need to find this side right here. So we know that 5 squared plus this thing squared equals 12 squared. So 12 squared minus 5 squared equals this thing. If that was too fast, start to get faster, because you should know that. So 12 squared minus 5 squared. We need to take the square root of that. Okay, since it's a decimal, and since this is not actually I'm not telling you that this is the height of a building or something like that. It's not an actual measurement in real life. Let's just leave it as the square root of 119. Okay, just leave it like that. And that, I think that it's prime, so I don't even think we could try to break it down. It may not be prime, but I'm not sure. I think it is. Anyhow, we're going to go ahead and do the rest of the 4 trigonometric functions. So let's go with the sine. The sine is the opposite over the hypotenuse. The opposite is the square root of 119. The hypotenuse is 12. Done. How about the tangent? Tangent is opposite over adjacent. Opposite is the square root of 119 again, over 5. All right. And the reciprocal of the sine is the cosecant. The reciprocal of the square root of 119 over 12 is 12 over the square root of 119. But remember, rationalize the denominator, multiply by the square root of 119 on the denominator and the numerator. So what's that going to give us? Square root of 119 times the square root of 119 is 119. And 12 times the square root of 119 is 12 times the square root of 119. You might see a pattern emerging. Rationalize the denominator can be quite quick once you see, all that happens is you're going to multiply by the square root 119 up here, and then you're going to have just 119 in the denominator. Okay. Last one, secant. Or sorry, we already had secant. We're going to do the cotangent. That's what we're looking for. The cotangent of theta is the reciprocal of this guy. That would be 5 over the square root of 119. But that's going to need to become 5 times the square root of 119 over 119. All right, that's 13. Oh, let's look at 19. We've got this picture of a right triangle. This is 12, this is 30, and x and y. Now, I think this is a little funny that they give you these problems, and then next they give you problems that are only slightly more involved. What I'm referring to is that in the next problems, not this one, but the next problems, they're going to say solve the triangle. Solve the triangle means find everything. Find the sides, find the angles. But this one they just say find x and y. Well, look, that's x and y are the two sides that are left to find. And we know 30 and we know 90. The only other thing that this problem isn't asking for is 60 degrees. They're not asking for this, but it's easy enough just to throw that in there. I think that's funny, but you might not think it's very funny. Oh well. So now, how do we find x and y? Okay, now that's a bit of a tricky thing to maybe come up with on your own. But think about this: that say the sine of 30 degrees, just for example. We might use something else, but remember, like the sine of 30 degrees, it's the same every time. No matter what the actual measures of the triangle are, the ratios of the sides to each other are always going to be the same. Okay, so why don't we use one of those ratios that's always the same to find these unknown sides. Couple the unknown side with a known side and one of the angles, and we've got something going there. Let's look at 30 degrees, and x, and 12. 30 degrees, x, and 12, that's the opposite side and the adjacent side. The opposite over the adjacent, x over 12, well, that is the tangent of 30 degrees. So the tangent of 30 degrees in this triangle is the opposite over the adjacent side. But we also know that the tangent of 30 degrees is a constant. We can go back, we can look it up if we want to. I'm going to, just because I'm pretending like I'm doing this as a student. So I'm looking at 30 degrees. That's on page 853 in our books. The tangent of 30 degrees is the square root of 3 over 3. So to solve for x, what do I need to do? I can ignore this. I now have this equation involving only numbers. To solve for x, I just multiply by 12 on both sides. So x is equal to the square root of 3 over 3 times 12. And the 3 and the 12 will cancel. This will become a 4. So x is equal to 4 times the square root of 3. All right. A number of things we could do here if we wanted to. We can use the Pythagorean Theorem. Let's do that. 12 squared plus 4 root 3 squared equals y squared. 144 plus 16 times 3 equals y squared. And let's see if this has a nice square root. It doesn't. Let's see if we can simplify it. Alright. So we can simplify the square root of, what was it, 192. So y equals the square root of 192. And 192 equals 64 times 3. 64 is a perfect square. It's 8 times 8, so 8 root 3. So y is 8 root 3, and that should be actually an 8. Okay. So let's go back in time, pretend like we haven't done all this work and we don't know what y is. We could use a trigonometric function as well, as opposed to using the Pythagorean theorem. So we could say, let's go with the cosine, right? 12 is a nice, not square rooty number. So look at 12, and we will use 12 and y and 30. Well, this is the adjacent side, this is the hypotenuse, so adjacent over the hypotenuse, that's the cosine. The cosine of 30 degrees is equal to 12 over y. Yeah. Well, what's the cosine of 30 degrees? It's always a constant, and the cosine of 30 degrees is the square root of 3 over 2. Alright, and now we want to solve for y. Now remember, it's just this equation involving numbers. So let's see, y is in the denominator. We got to do something about that. Let's multiply by y on both sides. So we get 12 is equal to the square root of 3 over 2 times y. And now how do I get this guy away from y? Well, I'll just multiply by its reciprocal. Y, because 2 is going to cancel 2, and the square roots cancel each other. So whatever this is, that's y. So y is equal to 24 over the square root of 3, only we need to rationalize the denominator. So this is 24 root 3 over 3. Okay, don't forget how this comes about. Don't just go with the shortcut and just know how to shift stuff around. Remember that we multiply by the square root of 3 in the denominator, that's where we got 3. Multiply by the square root of 3 in the numerator. Okay, except for, we must have done something wrong here. Because we should have gotten 8 times the square root of 3. Oh, because, of course. 3 cancels with 24. That was the problem. 3 cancels with 24, and we get 8 root 3.